we want to work in MySQL, so we're going to open MySQL Workbench. And we've already made this connection. We've already done some SQL coding before, so we're just going to open this connection right here. And it starts us off with this script, and we can see that our database is still here. Our tables, sales data is still there. Still has all these columns that we made. And if we go in and if we look at the table, sales data table, we can see that we still have the data there. Okay. And what I want to do now is well, let's go just revisit the data real quick and remind ourselves of some of the SQL code. So let's first select all the, and so we have, we want to select all from sales data. Now, of course, I always end with a semicolon. And if we just want to run this line, at least on PC, the shortcut is hold down Control and hit Enter. And you can see it's not going to work. And one reason is no database was selected. Now, before what we did was we said use comp metrics, because comp metrics was the database that had the table called sales data. Now, another way of doing this, instead of just having it saying use comp metrics, we can say select all from, and we say comp metrics dot sales data. And this is just a way of saying use this database and then this table in it. That's helpful if you're bringing in more than one database at a time. I'm going to run this one line, and yeah, it works. Now, actually, what I'm going to do is I'm going to start with first the command, just use comp metrics. And then I'll just be able to run this once, and then I won't have to specify which database I'm using again. Now let's remind ourselves just how big this data set is. So I'm going to come in here and I'm going to, suppose I want to, I've got this really big table with all these different SKUs and quantity sold and things like that. Suppose I want to know just how many different SKUs are in the data. I want to count the number of unique values of SKU in the data. Well, I learned how to do this by, how did I do it? I just Googled it. I came in here and let's say, Googled something like count number of unique values in a field, MySQL. And then how do I count the number of unique values in a column? Values in the field in SQL. Yeah. And so I found a page that gave me the code on how to do it. And so I learned I can go in here and I can say, okay, select, and I want to count the number of distinct values in the variable name SKU from sales data. And we're running that. I'm not going to pause this. So there's 500 different SKUs in our data. And of course, in a real grocery store, you could have many, many more than that. So this may seem like a large data set, but it's actually quite small compared to most grocery store data sets. How many different let's say stores do I have? Now select count the number of distinct stores from sales data. It should say 3 if it's running right, because I know there's only 3 stores in our data set. Yes, 3. And suppose now I just want to count the total number of rows in the data. Remember, star means all, so I'm going to count all from sales data, and almost 3 million observations in the data. Now, oftentimes in data sets like this, what we're wanting to do is do something like go into, say, a store and let's say find the SKUs, the number of food products that generate the most revenues, and maybe get the total revenues of each SKU, put them in order so we can see which which food products in our grocery store bring us in the most money. And so we're going to start to do something like that now. So we're going to say, okay, we want to select, and the things we want to know are, we want to know the SKUs. We want to know SKU, and we want to know revenues. But remember, in our data, here and look at our data, we do not have revenues. We have the quantity sold and the price. But we also know that quantity times price would be the revenue of this SKU sold on that day. Now, normally in Excel, what you would do is you would make a new column where you multiply quantity times price, and you have a new column for revenues. But when you're working with data sets like this, you often don't have permission to change the data set. You can't just go in and add new things, but you can make transformations and select from it. And that's what we're going to do here. So we're going to, we'll select into SKU, and then we want revenues. And so what we're going to do is we're going to take the sum of quantity would be quantity sold, quantity sales actually. Remember, we can always look over here and remind ourselves what the field names are. So quantity sales times price. So for any given grouping, let's say by SKU, by store, something like that, what we're doing here is we're saying we want the total revenues over all that. And we want it from sales data. Now, if we just stopped here, actually it's going to say it won't work because there's no group by. Whenever you are making a transformation of data, you always need some kind of group by. And so what we want to do is we want to group by SKU. And we're going to be adding a lot to this one command. So I'm going to start breaking it on different lines. And I'm going to just put this right here, semicolon at the end. So let's run this. And now when I'm running multiple lines, instead of Control Enter, I'm going to go Control Shift Enter. And we are running. And what it should give us is a list of each SKU and the total revenues for it. Yes, so each SKU and total revenues. Now suppose I just want the total revenues by SKU from one store. So now I'm going to go where store equals Perkins. And let's see if we can run that. I might need to put Perkins in parentheses, quotation marks. Yeah, looks like we need to. So now I need to do it where store equals Perkins. It's running. That looks like a good sign. Now, I haven't actually saved the script file yet, so I'm going to go ahead and do it now before I accidentally lose some things. I'm just going to save this. You can name it whatever you want, of course. I'm going to name it as script 3. Okay, now suppose we want to know the total revenues for each SKU for the Perkins store, but we want it to be just for, let's say, last year. Well, what kind of years are here in the data? They go through, to see that, we can go, let's see, select, show you how to do something. So where store equals something, so we want the store to equal Perkins and year. Let's say we want to look at 2023. We want to look at total revenues per SKU for 2023. And so we want to be able to say something like year equals 2023. But there's a problem here. We don't have anything that says year here. There's no variable, there's no field that says year, but we do have the date it was sold. And you can see that year here is in blue. That means it's a function. And if you look it up, what we can do is we put date sold in there. And what this does is it turns every date into a year. So let me give you an example. Suppose we go select year, date sold, and we want date, and we want SKU, and we want price from sales data. If we run that, date sold is what that was supposed to be. Run that one line by holding down Control and hitting Enter. And now, so we have this date, the date it was sold, January 1st, 2019, and now we have this new variable with the year, 2019. So it took this year formula took a specific date and converted it to just what the year it was. So now that I know that should run, I don't think I need to put 2023 in parentheses, but we'll see. Let's see how this works. It's running, so that's always a good sign. And now for this SKU, we have the total sales and total revenues, and the revenues are lower. That's because it's just for 1 year. So that actually looks right. Now let's notice these aren't in any particular order. And I would like it to show me to start with the SKU up here that has the highest revenues. Well, we can do that just by going, okay, we group by SKU, but we want to order by quantity sales times price. And we want it to be descending, meaning give us the first, we want to group by SKU, but first give us the SKU with the highest revenues per store in the year 2023. All right, let's run this and see how it looks. Okay, this looks like it works. So the total revenues are right here, and they do go down. And so the SKU 118-66637, at least for the Perkins store in 2023, generated the most revenues of any other SKU. Of course, this is it's 500 of them here, so it's pretty long, but certainly you can easily export this to a spreadsheet. So if you wanted to export this to a data, you can just go right here and save it as, you can save it as some different things. I always think it's best to save it as CSV files, meaning the fields are separated by commas in the data. It just seems to work best. Now suppose here, instead of it giving me, let's say all 500 SKUs, suppose I just want the top 10. So I can just go limit 10 and run it, and then it should just give me the SKUs, the 10 SKUs with the highest revenues. And I know I'm showing you these commands really fast and stuff. Yeah, so there's only 10 here. But, you know, remember, I learned all this just by Googling stuff. Just by looking up how to do things and then playing with it and trial and error. Now I'm going to save this to make sure I don't lose anything. So I have some code that's working here, so I want to preserve a record of it in case I want to go back and look at it. Now let's say maybe I want to look at some of the top selling SKUs by each store as well. So I want to look at all 3 stores now. So I'm going to get rid of this. I only want to look at the year 2023. I want to know both the SKU and the store. And I want to group by both SKU and store. Let's see how this code works. Okay, so we have these 3 stores here, and we are still sorting them by the highest to lowest revenues. So for each store, looks like the same barcode, the same food product, yields the highest revenues. And there are some revenue differences between the stores. For instance, for this particular food product with the barcode 101866637, Stillwater store sells more than the others. Of course, yeah. And by the way, if you ever want to put like a comment in here that you make sure the MySQL will never read it as a command, you can just do this. And so whatever you put between these two things, anything I type here will be ignored. And so, you know, I've got all this code that's working very well. Actually, it looks like I need to do this. You can tell this doesn't look right. Everything's in blue, where some things should be in blue, some in black. I just made my mistake there. You know, and again, how do I do that? So, how do I learn that? Just Google how to insert a comment in MySQL code. And we see some different ways of doing it. That's one of them. I guess I just stumbled on a different way of doing it. Yeah, multiple line comments, so you can do this. And so when doing that, that means I can select everything, this whole code right here. Maybe I want to, if I'm starting from scratch next time, and I can run this whole code. So I'm going to say use comp metrics. So I'm going to save this, save script 3, and then watch, I'm going to exit out of everything. And then I'm going to open it back up. Connect to my database again. And see, let's get to which I can start over. Okay. And let me open SQL script. I saved the script S3. I'm going to open this up. I'm just select everything by down control and then hitting A. And then I could hit this, or I could do the short key, hold down control, hold down shift, enter. And then everything should run and give us the exact same numbers it gave us before. Yes. I'm going to do one last thing here, and I'm going to add some explanation of what I'm doing here. At some point in class, we study something called the economic order quantity model with stochastic demand. That's where we look at the point at which inventories have to fall, at which we trigger a reorder of the inventories. And for each SKU, we need to know average daily sales and the standard deviation daily sales. And let's do this for the 50 SKUs with the highest average daily sales, and only for 2023. The economic order quantity model with stochastic demand is going to work like this. It says we're going to reorder Q star units. Maybe this is an input, so we reorder in Q star units whenever inventory on hand of the good falls to S star. And then S star is calculated like this. We take the average daily sales of the good of the SKU and multiply it by the lead time in days. Lead time being the number of days between the time you place the order and the order arrives. And then you add to that some safety factor. We usually use the number 2 for a safety factor, times the standard deviation of daily sales, times the square root of lead time in days. That means for us to be able to calculate S star, to use this model in managing inventories of these SKUs from our data, we need to get the average daily sales and the standard deviation of daily sales. And that's what we're going to do right now. Let's remember what Q star is. Q star is the number of units you order every time you place an order. And we have learned that the optimal Q star under many circumstances is the square root of 2 times R times D divided by H, where little r is the cost of placing an order. Every time you place an order, how much does it cost you? Big D is your annual demand, how much you think you'll need of the product all year. And little h is the cost of holding just 1 unit in inventory for 1 year. And one thing to know why this works is we have to recognize in these data, I'm going to pull it up again, for each SKU and each store, there is only one record of sales for each day. So this is 416 units of this SKU sold on January the 1st, 2019. There would not be another record of that SKU quantity sales on that same day. We want to say, and for the Enid store. So what we want to do, we want to select some data. And we know we want it by SKU, so I'm going to select by SKU, comma, I want the average daily sales, so average quantity sales. And we're looking at quantity, not revenue, because with inventory management, we're thinking about how many units of the input or product to reorder. We also need the standard deviation of quantity sales. And of course, how did I know that there's a function called average and standard deviation? I looked it up. Now this isn't turning in blue. It may be that they like some other spelling better, but I know the STD works. Okay, so I want the SKU, average quantity sales, and standard deviation of sales from, I'm going to use multiple lines. And I know I always want to end with a semicolon, so I'm going to go and put that at the bottom there. I want to select those variables from my table sales data, where the year, the date sold, and then you put that in the year function. It'll tell you the year was sold. I want to know the year. I want it where the year equals 2023. And store equals Enid. Now I'm going to add more, but I like to add a little code at a time and then run it and see if it runs. It's easier to debug that way. If you put a lot of code in and then you run it doesn't run, you're not sure what parts have an error. Let's run that. Oh, we do need a group by. We have this, we're not getting raw data, we get functions of data, so we need a group by. And I know I want to group by SKU. This is looking good. Some other things I need to do. So I know I want the 50 SKUs from the Enid store 2003 with the highest average daily sales. So I know I want to order by the average of quantity sales. And I want a descending. Let's run this and see if it goes. Yeah, we have the highest average daily sales, lower, lower, lower. And the further I go down here, the lower those daily sales tend to go. and I want to limit it to 50 SKUs. Let's run this again. This looks correct. And okay. Get rid of this. I'm going to pause here for a second just to kind of show you some easy mistakes to make that will make the code not run. Suppose in this select command, suppose we forget to put a comma there. We can already see from this X mark, it doesn't like it. We can choose all this and then try to run it, and it won't run. So we need to make sure we have commas in the right place. If I put a comma here, oh, so again, you can see that's not working. Spell Enid wrong. I forget that I in it. Let's see what happens when we run it there. Now it returns no data. So if it doesn't return any data down here, you know you probably did something wrong. And of course, suppose we forget to do the colon down there. And then we try to run it. Since it's the last code, it might, yeah, it'll actually run. But if there was, it still could mess it up. It just happens to run because it happens to be the last code on that script. So everything looks good here. I'm going to run this one more time, getting the data that we need to calculate the numbers for our economic order quantity model with stochastic demand. And now I want to export this to a sheet that can then be read into an Excel spreadsheet. My model is going to be in a spreadsheet. So I've got my data here. I'm going to export it. And I already have a file already made. I'm just going to in general, you don't want to overwrite files, but it just happens that I do want to overwrite this one. CSV file, again, that means the fields are separated by commas. That's the best way to store data. And I'm going to save. In my instance, I'm going to say yes, okay, to overwrite it. But if you ever see that question, do you want to overwrite data, pause and make sure that's what you want to do. Let's go look and see what that data looks like now. So I'm just going to open it in. So SKU, average quantity sales, standard deviation. Here we go, and just 50 of them. That looks right. Now I had already started a spreadsheet for the economic order quantity model where I have information on ordering calls, holding calls, lead time, my safety factor I want to use, things like that. I now want to bring that data I just got from MySQL, and I want to bring it in here. And so I'm going to go to Data, Get Data, and mine happened to be from a text file. To find where that data was, it was right here. Just load the data. And it's going to create a new sheet where it puts it. And I like to, for a number of reasons I don't want to get into, I like to copy it and then paste special just the values over here in my sheet. Okay. Now I'm going to make the calculations for our economic order quantity model with stochastic demand. Let's go ahead and build our economic order quantity model, meaning we want to go ahead and put in our equations that tells us for each of these SKUs what the Q star is and what the S star is. And I want you to notice something. In the sheet that I made, I've got my ordering cost as $15,000, but notice I've given this a name. COEFR, so for coefficient R. So whenever I want to refer to ordering costs, I just write that name instead of the cell value. That way when I go to copy and paste, it remains referring to that coefficient value, and the address will not change. Likewise, I made holding cost coefficient H. I made my lead time coefficient big L, and my safety factor coefficient K. I know one of the first things I'm going to need is to anticipate what annual demand is going to be. Now we don't know exactly because demand here is stochastic, but we can estimate it. And we're going to estimate big D as, well, if on average each day we sell this many units, then each year we expect to sell about 365.25 units. The 0.25 there accounting for leap year. So I'm going to do that. And then now I want to go ahead and put my S star here. S star is the point at which when inventories hit S star, that triggers a reorder. And we remember that S star is calculated as the average daily sales times lead time plus our safety factor, which we call coefficient K, times the standard deviation of sales times the square root of lead time. And do notice that I can type COEFL for lead time. I can also just come up here and select it, and it's going to not put the cell address but the cell name. So average sales times lead time plus the safety factor plus standard deviation of sales plus the square root of lead time, and that gives me my S star. And then finally I need Q star. And remember, Q star equals the square root of 2RD divided by H. So I'm going to go square root of 2 times R times big D, annual sales, divided by H. Oh, and something went wrong. Oh yeah. Times big D. All right. And so what this means is that our model is saying for SKU 679-92122, whenever inventory on hand, meaning the amount of that SKU, falls to 3,487, that should trigger a reorder. And when we reorder 368,151 units. As you can tell, inconsistency in decimal places annoys me. I want to point out something. Some of these numbers may seem absurd. So for this SKU, we only use about 90,000 a year, and yet every time we make an order, we're going to be ordering 368,000. And so we're only going to be ordering some every couple of years. Well, that's just a product of these numbers. It's because the ordering cost is so high and the holding cost is so low. So if we change the holding cost from, say, 0.02 to 0.2, now we come over here, and now every time we make an order, we order just a little more than what we need each year. So when the holding cost goes up, we make more frequent orders and we keep less in inventory. Now suppose the cost of ordering goes down to just 5,000. Come down here, and now we need 90,000 a year, but each time we reorder about 21,000. So we're going to be making multiple orders per year. And then what you can do with all this, so this is information that can then be entered into an automated system. So a lot of businesses are going to have information that keeps track of current inventories, and the computer system can be set up such that once it measures computer inventories, of this SKU reaching 3,487, it can send a message to the manager that it's time to reorder, or sometimes it can be set up to reorder automatically, and the computer system itself can say, well, whenever we reach 3,487 units, it's going to automatically order 21,255 units.